Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving an exponential equation with complex numbers. If you're new to complex numbers, go ahead and check out my lecture videos and ask a lot of questions. If you like algebra, number theory, and trigonometry, and even if you don't like them, give it a try. Check my other channel, Cyber Math, that's cyber with an S. So let's go ahead and see how we can solve an exponential equation like this. You probably don't see very much of these in textbooks, do you? They're kind of rare, but you can find quite a few on my channel. Go ahead and check them out. I made different playlists. So we have a complex number, 1/2 plus root 3 over 2i, and that is raised to the power z. Z is a complex number, and the result is I, which is really weird, right? How do you take a complex number like this and turn it into something simpler like I? That's what we're going to explore in this video. So to understand how this works, there's a couple ways to approach it. Euler gave us a beautiful formula, which is if you have a complex number, you can write it in polar form. In other words, if you have something like cosine theta plus I sine theta, by the way, this would be the standard form with trigonometry. And this can be written as e to the power I theta, which is beautiful because you take something trigonometric, turn it into an exponential, including some imaginary numbers, real numbers, so on and so forth. So it's a beautiful relationship because Euler is awesome, needless to say, right? And how can we use this though, right? So we should be able to do this as well. Of course, a complex number in general can be written as r times e to the I theta, where r is the modulus or the absolute value. Again, I go over these in lecture videos, and theta is called the argument. But just to give you a quick overview, it's basically going to look like this. You have the complex plane, which is made up of the real and the imaginary axes, and you have a number, some number z or whatever. And then obviously when you connect it to the, to the origin, you're going to get some distance here. This is r. R is the absolute value or the modulus. And our number obviously is going to make, because this is kind of like a vector, right? It's going to make an angle theta. But one thing about theta, I have to tell you that theta is usually the smallest angle, and that is considered the principal argument, because you're allowed to add multiples of 2 pi to it, and you're going to get multiple branches, so on and so forth. That's a long story. Let's get back to the problem. How can we use this information, right? So here's what we're going to do. The question is then going to be, how do you write this using trigonometry or exponentials, polar form, right? How do you write this in polar form? So here's what you need to remember. This is actually, if you know this, this will be super helpful. This is the cosine of an angle, and this is the sine of an angle. How do I know that, though? Because they're less than 1. And if you add the sum of their squares from the Pythagorean theorem, you're going to get 1. So we're basically, this is a point on the unit circle, in other words. But to find the angle, we're going to set this equal to cosine theta and set this equal to sine theta. And cosine of which angle do you think is going to be theta? And you have to think of the smallest angle between 0 and 2 pi. And that will be 60 degrees, right? Or you can write it as pi over 3 radians. A lot of times we use radians in polar form. So theta is found, which means we can write this. And by the way, r is 1 here because of the absolute value definition. And so we can now write this number as e to the power, again, going back here, z times, r times e to the I theta, but r is 1 and theta is pi over 3, so we can write it as e to the power I times pi over 3. But again, that's not the only angle that works, because we're allowed to add multiples of 2 pi, which you can write as 2n pi. N is an integer in this case, right? So we're going to go ahead and put that whole thing in parentheses. Now, if n is equal to 0, then you get e to the power I pi over 3, which is going to be the principal value. Okay? So, even though they all represent the same number, there are infinitely many ways to write it. There are multiple representations. In other words, it's called multi-valued. Okay? Now, how does this help though? We can go ahead and plug it in here. We can kind of write it as e to the power I times pi over 3 plus 2n pi, that's what I meant, 2n pi. And then this will be raised to the power z, and the answer is supposed to be I. But you can do the same thing with I. How do you write I in polar form? Well, I is just going to be 0 plus 1I. In other words, it's represented by the point 0, 1, which is right here. And its distance from 0 will be 1 unit. And the angle it makes is going to be pi over 2 radians. In other words, I can be written as e to the power I times pi over 2. But again, the same thing applies. This is just the principal value. You can add multiples of 2 pi. Don't use the same n because it could be different. Let's just use k, 2k pi. And in this case, n and k are both integers. Did I say that? I think I said it for n, but let's write it one more time. I probably said it somewhere here. I don't know. Maybe I didn't. So this is our equation, and I know it kind of looks complicated, doesn't it? But you can kind of multiply things together and solve for z. But before we get into that, I want to show you something else. Because could we approach this problem differently, right? So one thing to keep in mind is I squared is -1. Oops, I forgot to say that. But it is what it is. I is the square root of -1, therefore I squared is -1. That's something that you should never forget. So can I just square both sides to make things a little easier? How do you know? There's no guarantee that it's going to make things easier though, right? Well, that's one thing you can do. You can square both sides. That'll give you I squared, which is -1. But you got to be careful because the solutions you find from there may not satisfy the original problem because maybe you're introducing extraneous solutions, if you know what I'm talking about. If not, you can always ask in the comment section down below. Regardless, you should always comment and write something in the comment section. Now, we could also cube both sides. You know why? Because cubing is going to give us something in this. Let me show you. If you take this number, and cubing is safer than squaring, right? Is it true? Maybe, maybe not. Okay, but if you cube this, you're basically going to get something like this. You're going to cube the first term. You're going to cube the second one. If you cube root 3, you're going to get this. And then here you're going to get 8. I cubed is -I. So this is going to be a -I. Okay. So here's how I do a plus b quantity cubed. A cubed plus b cubed. And then I do 3ab. 3 times 1/2 times root 3 over 2i. And then multiply by a plus b, which is 1/2 plus root 3 over 2i. Basically my version of doing the binomial theorem with n equals 3. Okay. Now you can go ahead and take this and distribute everything. And when you do, you're going to get something like 1/8 minus 3 root 3 over 8 over times I. Here you're going to get a 3 root 3 I over 2 times 2 times 2, which is 8. Uh-oh, they canceled out. And then when you multiply these two things, you're supposed to be getting 3 root 3 over 4, 3 times 3 divided by 8. And that should be 9 over 8, right? Let me double check. Oh, there's an I squared, so that's going to be a minus sign. And that should give you 3 root 3 over 4i multiplied by root 3 over 2i. This will make a 3. That'll make a 9. -9 over 8. Great. These two are going to cancel out. That's going to give you -8 over 8, which is -1. Uh-oh. This is a number whose cube is -1. You know what that means? It means that this number is one of the cube roots of -1. Does that help at all though? Maybe. I don't know. You can just cube both sides. I cubed is -I. And from there, you still have to do a lot of work. So this is probably the safest way to do it, I would say. Let's go back and try to go from here. We're going to simplify and solve for z. Okay? Okay, let's see how we can proceed. Now, we have this equation. And now we're going to do the following. We're just going to multiply. And since they both have e at the base, we can go to totally forget about it. So we can just write it as iz multiplied by pi over 3 plus 2n pi. And that is equal to I times pi over 2 plus 2k pi. And then from here, we should be able to solve, right? I cancels out for sure. And then you can go ahead and divide both sides by this. And that should give you the value of z. By the way, we're going to check our results against Wolfram Alpha to see if we get something similar. But again, one more thing that I want to say is whenever you get something like a complex number to another complex number, like this, let's say w to the power z, you can always write it as e to the power z ln w. So in our case, we have 1/2 plus root 3 over 2i raised to the power z, in this case w happens to be the base, you can write it as e to the power z times ln 1/2 plus root 3 over 2i. And this should equal I, right? Now, I can be written in exponential form, or you could just leave it like that and use ln again, natural logs, because the only problem with that approach is you need to know how to ln a complex number. And that's a complex logarithm. How do you do that? There's a formula. If you ln a plus bi, you get ln the absolute value of a plus bi, which is the square root of a squared plus b squared, plus I times the argument of a plus bi. In this case, it happens to be pi over 3 because we know that, right? It's at least the principal argument. And this should be 1. So this is 1. So ln 1 would be 0. You don't have to worry about it. So the only thing you get from here is going to be I times pi over 3, which is this part. I times pi over 3 will be multiplied by z, and it'll be equal to that. And you can use ln again. But this is probably the easiest way to do it. Let's go ahead and do that. Pi over 2 plus 2k pi divided by pi over 3 plus 2n pi. Something interesting is going to happen here, by the way. Let me go ahead and clean this area so I can show you. What we can do is we can actually simplify this because we have pi as a common factor, don't we? So let's go ahead and factor out the pi's first, or divide everything by pi. Oops. Pi cancels out, and you end up with 1/2 plus 2k divided by 1/3 plus 2n. Wait a minute, does that make sense at all? Okay, let's go ahead and multiply the top and the bottom by 6, which is the least common, whatever, multiple. Distribute that, you're going to get 12k plus 3 divided by 12n plus 2. And that should be the value of z, where k and n are integers, right? Now, what happens if k and n are both 0? That's an interesting case. That would give you z equals 3/2. But would that work? You can always go back and check it out. Like, if I raise this number to the power 3/2, is that going to give me I? How do I check that? Well, remember what I told you. I told you to cube this number, right? That's why. When you cube this number, you get -1. So this becomes -1 to the power 1/2, which means the square root of -1. But there are 2 square roots, but the principal square root should be I, in my opinion, right? So it looks like it's working. 3/2 is working, which is kind of interesting, right? This problem does not have a complex solution. I mean, a non-real solution. It does have a real solution, which is interesting. Let's go ahead and check out our results with Wolfram Alpha. Are you ready? Ready, set, and ta-da-da-da. Where are they? Here we go. Okay, is that the same thing? No, not really. Why did Wolfram Alpha use a single integer? It's probably going to turn out to be the same thing. But anyways, that's for you to decide, because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out Cyber Math, which is my other channel, and aplusbi, and bye-bye.